Hey, Algebra 2 students, let's go ahead and get ready for the first test that you'll be taking next week for me. I believe I have that scheduled on Tuesday for you, so you'll be receiving that in your work packet that you'll be getting here in just a couple days. You can see the lessons that our test is going to be over, and in your packet, I also went ahead, the one that you should be receiving this week, I put your test review list with all the topics like we would go over it within class. So follow along with me, and you can make your notes right on there, put down the examples. Remember, this test that you're going to be taking, it's an open note, open book, so make sure you get some examples down, as these will look very similar to the ones that you'll be doing on your test for me next week. So let's go ahead and start off in the first section, where we talked about from lesson 66 some different kinds of polynomial equations and how to correctly solve them. The first two questions that you'll be solving for me look like the following, and the directions will say to solve by factoring. If you look at the question, x to the third minus 2x squared minus 24x equals 0. What do those three terms have in common? They all contain an x. So I'm going to yank that out to the front first. When I pull the x out to the front, that leaves me with x squared minus 2x minus 24 is equal to 0. And I failed to mention the equation did need to be set equal to 0. I believe I have that done for you already on the test, but do double check that the equation is set equal to 0 first. After you take out your common factor, notice inside the parenthesis you have your x squared. When you have your x squared, that was the kind of question that you can break down into two separate parentheses, so that's what we're going to do next. To help you fill in those two parentheses, what can you multiply to get your 24? And you can add it together to get the the negative 2. That would be a positive 4 and a negative 6. Notice the x is still in the front of the parentheses, so that didn't change at all. I have my x plus 4 and my x minus 6 from the factors of our quadratic part of the question. So 4 minus 6 was negative 2, and 4 times negative 6 was negative 24. Now that I have my equation factored, we can go ahead and write down our answers. I have three different factors, therefore I have three different answers on this question. And that makes sense because the question said x to the third. Beginning with the first factor of x. There's no number over there, so what number does that correspond with? A 0. The second factor of x plus 4. Remember when we wrote down our answers, we gave the opposite of what we had in the parenthesis, so my second answer was negative 4. The last parenthesis, x minus 6, given the opposite, is my third final answer, a positive 6. Remember, just a way that you can quickly check this, you would take each of those numbers individually, put them back into the equation for all of the x's, and when you do that, it should give you 0 for the final answer. So that's something that you can do as you're taking your actual test if you want to. Plug your answers back in. Do they actually give you 0? Let's do one more of these factoring questions. As the next question, we're going to have to take out a number and a variable when we go to pull out our common factor. So 2x to the fourth plus 16x to the third plus 30x squared is equal to 0. Again, the directions will say solve the following equations by factoring. So take a look at these numbers, 2, 16, and 30. What do 2, 16, and 30 all divide by? The number 2. Take a look at the variables, x to the fourth, x to the third, and x squared. When you're pulling out your variable, we always took the one that had the smallest exponent, so I'm going to take out 2x squared. When I take out 2x squared inside of the parenthesis, that's what I have left. My x squared plus 8x plus 15, and our question still equals 0. The part that we have inside parenthesis again is the x squared part of our equation, and we can break that down into two separate parentheses. What multiplies to give me 15, and I can add those numbers to get an 8. That would be a 3 and a 5. So I have the 2x squared still in the front, and there's my two parentheses, x plus 3 and x plus 5, and that was equal to 0. So the signs are the same inside of the parenthesis. That was because of the plus at the end, and they're both positives because of the 8 being positive as well. We have three different factors, so we're going to give three different answers. Starting off with our first factor of 2x squared. Now remember, the 2 doesn't affect the answer. It's only anything that was being added or subtracted. Nothing's being added or subtracted in the front, so the first answer is still 0. The second part of the question, the x plus 3, would give me my second answer of negative 3 for the opposite, and the same thing for the last parenthesis. X plus 5 means my final answer would be negative 5 for the third parenthesis. Now, just because there was an x to the fourth in the question doesn't mean I have to have 4 answers, just as the most answers that I can get. Remember we talked about our multiplicity. One of the answers could show up multiple times. The one that shows up multiple times here is the 0 because that front x said x squared. You don't on your test need to tell me the multiplicity. You would just need to give me those 3 answers and that would be your final solution. You could check it just like I mentioned on the last problem. Put those numbers individually in for the x's and your equation should equal 0. So that would be like questions 1 and 2 that you'll be facing. Out of lesson 66 as well, we talked about another kind of polynomials where we were able to solve. However, we couldn't use this idea of factoring to start with because there was nothing they had in common and it had those 4 different terms. So these questions on your review list will go with numbers 3 down to 10. It was a multi-step question, so I've broken the problem into all the different steps. So let's go and work through this question together. X to the third minus 2x squared minus 11x plus 12 equals 0. Again, you can't do these like the first set of questions because there is no common factor that you can move out to the front. So the first thing that we had done with these questions is we had listed out factors of the constant. The constant on this question was positive 12. What can I multiply to get a 12? I could do 1 times 12, 2 times 6, or 3 times 4. Don't forget when we were listing out the factors, we had to include that plus or minus sign in front of all of them. So I plus or minus 1, plus or minus 2, all the way down through the numbers that I set. So that would be like question 3. Question 4 then is going to ask you for the factors of the leading coefficient. Well, the leading coefficient was the number at the front of the question. Well, in the front of the question is x to the third. What number is in front of the x to the third is technically a 1. So what can I multiply to get to the number 1? It's just 1. Don't forget again, you have to include that plus or minus sign. So the factors of the leading coefficient are plus and minus 1. Now that you have the constant as well as the leading coefficient listed out with your factors, the next thing that we did was we used what was called the rational root theorem. The rational root theorem allowed you to take the factors of the constant divided by the factors of the leading coefficient to come up with the possible roots or the possible answers that we had in this question. So this is what you're going to do like on question 5 for me on the test. The question is going to say to list out all of the possible rational roots. Well, again, to do that, we're taking the constants that you just wrote in question 3 divided by the coefficient that you just did in question 4. Now, what's nice about this, the coefficient in question 4 was 1. Well, dividing by 1 doesn't do anything, so the rational roots happen to be the exact same as the constants that we just listed out in question number 3, all 6 of our numbers with our plus and minus sign in front of them. Okay, so that's like questions 3 through 5. Now, in question 6, here's where we actually had to kind of get into some of the arithmetic. You had to determine which one of those rational roots gave you a remainder of 0. Remember, one by one, we put them in for the x's, and we saw which one worked. So let's go ahead and start off with our positive 1. Hopefully that's the one that works. Otherwise, we have to do a lot of different steps here. So let's start with 1. 1 to the third is 1. 1 squared is 1, so times 2 is 2. So 1 minus 2 is negative 1. The next one, 11 times 1 is 11. So I had negative 1 minus 11, and that's negative 12. Negative 12 plus 12 does give me 0, so the very first one that I used worked. The rational root that gives me my remainder of 0 is the number 1. Now, please make sure that you get that answer correct. Remember, all that I did was I started with my positive 1, and I put it in for all of the x's. If you mess up this step right here, unfortunately, it's going to mess up the rest of the question. So make sure that you are thinking carefully here as you're working on question number 6. Now, question number 7 is going to tell you to divide using the root that you just got from question number 6. Well, how did we divide? We used our synthetic division. Inside of my division box, I put the root that I just found, my positive 1. Next to my division box, I listed out my coefficients from the problem, 1, negative 2, negative 11, and positive 12. To do synthetic division, we always drop down the first term, so I brought down my 1, and then we started multiplying by the box. So 1 times 1 was 1, negative 2 plus 1 was negative 1. Negative 1 times the box, negative 1 times 1 is negative 1. I wrote that under the next piece. Negative 11 and a negative 1 was negative 12. Negative 12 times the box is negative 12. I wrote that under the next term, and 12 and a negative 12 is a 0. Remember, you should have that 0 at the end of this division process because the root that you have inside of the box was the one that gave you a remainder of 0. And that's where the remainder shows up in our division problem. Now again, please be careful on this division process because you're going to use that answer to help you on the next question. Okay, so now we're ready for question number 8. On question number 8, it's going to say to write the original problem as 2 factors. Well, the original problem is still what I have up here on the screen. And I even wrote on the test there's a hint for you to use. It's going to say the 2 factors, number 1, it's from the root that you just did. Well, what was the root that we just used? 1. However, the factors are inside of parentheses. Remember, things inside of the parentheses, we have to do the opposite, just like we did back in questions 1 and 2. So because my root is positive 1, my first parenthesis is going to say x minus 1. The second hint that I have next to this question on number 8 is going to say the second factor includes your answer from the division problem. Well, in the division problem, we had the numbers 1, negative 1, and negative 12. After we do synthetic division, the highest exponent is 1 less than we started with. I started with an x to the third. That means my division answer is going to start off with an x squared. And notice that's what I have inside my parenthesis. I have 1x squared, or just x squared, minus 1x, or just minus x, minus 12, and our question still equals 0. You're going to keep that equals 0 all the way through your question. Okay, so that's number 8. We just wrote the original problem as 2 factors, using the root that you found back in question 6, I believe it was, and then using your division answer from question 7. Question 9. Question 9 is going to tell you to factor the quadratic polynomial. What does that mean? The quadratic polynomial is the part that has the x squared. Just like you saw back in questions 1 and 2, once you have the x squared, you can break that down into 2 separate parentheses, and that's what you're going to do here on question number 9. Now, my hint next to question number 9 is going to say your answer should include 3 parentheses. One of those parentheses is the same as from the root. Well, what was our root? It was 1, and that gave us our parenthesis of x minus 1. So don't forget to move that root down, that parenthesis down, into your answer for question number 9. How did I correctly factor the quadratic parts? What multiplies to give me a 12 and adds together to make a negative 1? It was my positive 3 and my negative 4. 3 minus 4 is negative 1. 3 times negative 4 is negative 12. Remember, the signs were different because of the minus that was in front of the 12, and my bigger number is the negative because of the minus that I had in front of the x. Again, make sure that we're correctly doing this factoring on question number 9 because your final answer on this question will come out of those 3 factors. We have 3 factors, which means we have 3 answers, and that makes sense because the original question had an x to the third. Don't forget, your final answers are the opposite of what you had in the parenthesis. So the first parenthesis says x minus 1, which means my first x was positive 1, and that was the root that we had answered back in question number 6, I believe it was. The second parenthesis says x plus 3. So what root do I have from that parenthesis? The x would be equal to negative 3. The last parenthesis says x minus 4. What root would I have out of there? Positive 4. So your final answer on question number 10 is going to say what are the answers or what are the roots. You would give me those 3 answers, the opposite of what you have from your parentheses. Now, one thing that, again, you can look for, you could put those numbers individually back into your question. Make sure that you do get a 0 for each of them individually. Also, these 3 numbers were in your list on question number 5 of the possible rational roots. Positive 1 was sitting there, negative 3 was sitting there, and positive 4 was sitting there as well. So that's something that you can think through. Does my answer make sense? Just like this one, as you'll face on your test next week, you do not need to use the quadratic formula to help you solve. That happened on a couple of our examples during the lesson as well as from our textbook, but that will not be the case for the one that I gave you on your test. You'll just need to factor to come up with all of your different roots. So that section went from questions 3 down to 10, and I try to break it down for you into that step-by-step process of how you need to correctly answer our questions. Let's go over 2 more things today, and then we'll finish up our review tomorrow during our lesson. The next thing that you'll be answering for me, you're going to have to use your circle. So even right now, make sure that you have your circle out so you can think through these questions with me. The first thing that you'll be answering, this is from questions 11 and 12, is you're going to be describing all of the values for a certain inverse trig question. And I've highlighted that word all because there's something that we have to remember goes in our final answer when it says to give all of the answers. Notice this question is a lowercase letter problem as well. How many answers did a lowercase letter question have? It possibly had 2. So I need to give 2 possible answers, but then I also have to include something because it said to give all answers. On your circle, remember the sign was the y's. So I need to look on my circle, where do I see the y that says square root 3 over 2? The first place that I see that is at 60 degrees. Notice I wrote 60 degrees, and then here's my extra part because it says to do all of the values. I put plus 360n. Now, you could also give your answers in radians. I'm just going to show these answers in degrees here as I'm talking through our review, but that would be possibility for you to give it in radians with a pi answer. Then your qualification at the end would say plus 2 pi n, but I think this is a little bit easier for us to give them in degree format. Now, as I mentioned, this is a lowercase letter question. Lowercase letter questions usually have 2 answers. 60 degrees is just one of the locations that had the y as square root 3 over 2. Where's the other one? 120 degrees. Again, because I have to give all of the values, that means I'm spinning around the circle, so I have to put that plus 360n at the end of my answer. So don't just give me the 2 angles from the picture that meet this requirement. That's coming up in a future section here. All of the answers, I spin around as many times as I want to, so I have to do the plus 360n. Let's do one more section together today with regard to our review list, and this is questions, I believe it's 13 down through 15, where you're going to begin dealing with inverse trig questions, but these are the capital letter questions. Remember, capital letter questions had one and only one answer to them. Hopefully, you already have on your circle the different qualifications and restrictions when it came to capital letter questions. I'll review them with you as we're walking through these 3 questions together. The first one I see here is capital letter tangent. Well, where was tangent restricted to? It was either quadrant 1 or quadrant 4. Quadrant 1 would be the case if you were positive. Quadrant 4 would be if you were negative. So let's go and take a look at the ratio or the number that I have. The number that I have in this question is negative 1. Well, that's a negative number. That means my capital letter tangent answer is going to be in the 4th quadrant because that's the restriction for our capital letter tangent questions. What angle in the 4th quadrant has a tangent that is negative 1? Now remember, for tangent, it's y over x. So if I need the answer to be 1, that means the numerator and denominator have to be the same thing. That way they'll cancel each other out. What angle do we see has the same x and y except for the negative sign? That's located at 315 degrees. However, 315 degrees is not the answer that I give on this question for the capital letters because we had to give it the fastest route to get to the 4th quadrant, and that was by giving a negative angle. So my final answer here would be negative 45 degrees. You can think through that. 360 minus 315 is 45, and I'm backing up. That's why it was a negative 45 in our question. All right, so let's do 2 more with our capital letters to make sure that you got the right restrictions. So cosine inverse, capital cosine inverse, negative root 3 over 2. So capital cosine. What restrictions did we use for capital cosine? It was either quadrant 1 if you had a positive ratio, or it was quadrant 2 if you had a negative ratio. Cosine was one that was different than the other 2 in the question. So again, quadrant 1, positives. Quadrant 2, if you had a negative for your capital cosine. If I take a look at this question, I notice my ratio is negative. So where is capital cosine negative? It's in the 2nd quadrant. I'm going to take a look at my circle. Where in the 2nd quadrant do I see my cosine, which is the x, being at negative square root 3 over 2, and that was located at 150 degrees. In the 2nd quadrant, I give the answer just like it appeared. Only in the 4th quadrant is where we had to put that negative number like I just showed on my tangent example. All right, so let's finish up today by looking at a sign question. So our sign restrictions, what did we have? Sign, capital sign, was positive in our first quadrant. Everything was positive in the first quadrant. And then the negative restriction for capital sign was quadrant number 4. So that one for sign is just like it was for capital tangent. Quadrant 1 for positives, quadrant 4 for the negatives. We take a look at our ratio, and it's positive 1/2. Positives means I'm in quadrant 1. For sign, what was our sign? It was the y. Where in quadrant number 1 do we see that the y is 1/2, and that is located at 30 degrees? In quadrant number 1, I give the exact answer that I see from the question. Only in quadrant number 4 again do I need to say a negative in front of my final answer. So tomorrow we'll pick up from questions 16 to 25, walk through some examples that we'll go over again for how to correctly answer those questions on your test.